Hello, my name is Lola Golden. I am a sport and exercise student at Baswick. Today I will be investigating inertia and momentum and how they are applied to sport. Inertia is a tendency of a body to resist any change in its state of motion. This means that an object at rest will stay at rest, and an object in motion will stay in motion, at a constant speed and in a straight line unless acted upon by an external force. The greater the mass of a system, the greater its inertia. A heavier object has more resistance to changes in motion, whether it's starting to move or coming to a stop. This is because when a system has more mass, it is harder to change what it's doing. For example, it is easier to throw a tennis ball than to throw a bowling ball because the bowling ball has more mass. A heavier tennis racket, e.g. 0.35 kilograms, has more inertia than a lighter one, which would be 0.25 kilograms. This means it's harder to change the direction or speed of the racket when hitting the ball, and the player needs more focus to accelerate it. This is why younger children/beginners use lighter rackets, as they can focus more on the technique and movement without having to exert their full force into it. Using a lighter racket creates an easier swing motion for the performer, as it takes less effort to change the direction of the racket than if they were to use a heavier one. A shot putter must overcome their own inertia and the inertia of the shot put when performing a throw. The heavier shot put, the more inertia it has, making it more difficult to accelerate, but once it's moving, it carries more momentum. This is why when competing, men and women use different weighted shot puts. For example, in the Olympics, men competition shot puts have a mass of 7.25 kilograms, whereas women use a shot put which has a mass of 3.99 kilograms. Inertia is a scalar. This is because inertia is a measure of how much a system resists being pushed or moved. It depends on the system's mass, which is just a number and has no direction. In sports like shot put, the larger athlete with more mass has more inertia, meaning it takes more effort to get their body and the shot put moving. This is important because overcoming inertia determines the performance of the athlete in their explosive movement. Momentum is the quantity of motion an object has, and it depends on the object's mass and velocity. It's a vector quantity because it has both magnitude, how much motion, and direction, which way the object is moving. Momentum is calculated by this formula. Momentum equals mass times velocity. When momentum is measured in meters per second, mass is in kilograms, and velocity is in meters per second. This means that a heavier object moving at a faster speed will have more momentum. When a football is kicked, a heavier ball, which is 0.5 kilograms, will have more momentum than a lighter ball, which is 0.4 kilograms, at the same speed. The momentum of the ball is what allows it to continue its path and interact with the player's body or goalpost. If we assume that the velocity at which the ball was kicked was 20 meters per second, we could calculate the momentum as momentum equals 0.5 kilograms times 20 meters per second, which equals 10 kilograms meters per second. Similarly, if a 0.4 kilogram ball is kicked at the same speed of 20 meters per second, its momentum would be momentum equals 0.4 kilograms times 20 meters per second, which equals 8 kilograms meters per second. This shows that a heavier mass of an object compared to a smaller mass of an object will have a greater momentum if both the objects have the same velocity. A rugby player weighing 100 kilograms running at 6 meters per second will have more momentum than a smaller player weighing 70 kilograms running at the same speed. Momentum in this case is crucial in tackles, as a player with high momentum is harder to stop. To prove this, we can calculate the exact momentum of the two athletes by using this formula. For example, to calculate the momentum of the player that has a mass of 100 kilograms, we can do 100 kilograms times 6 meters per second, which equals 600 kilograms meters per second. For the 70 kilogram player, we would calculate the momentum by doing 70 kilograms times 6 meters per second, which equals 420 kg/m per second. This clearly shows that the momentum of the heavier player outweighs the momentum of the lighter player. If both players were to tackle each other at this momentum, the heavier player will win the tackle, as he will be harder to slow down. Momentum is a vector quantity because it has both magnitude, how much momentum, and direction, where the object is moving. For example, the momentum of a football is different if it is kicked forward compared to if it's kicked backwards. In rugby, players use their momentum to push forward during tackles. Players who maintain their speed and momentum during a tackle are less likely to be stopped by their opponent. This is a key component of stability and force application in contact-based